Alrighty, so today we're going to talk about solving exponentials. So exponentials written as a to the b, or obviously we're going to be using numbers and x's, but a is what we call our base, b is our exponent, so let's say we have an example that looks like this, where we have 2 raised to the x plus 3 equals 2 raised to the 2x. So to solve for exponentials, we must have the same base. Solve for exponentials. We must have the same base. In this example, we do. Makes it a lot easier. All right. The reason we need the same base is that if our bases are the same, then our exponents have to be the same. Okay, since these are both base 2, okay, we know that for this equation to be equal, then our 2 exponents need to be the same. X plus 3 has to equal 2x. Subtract x. We get 3. And by 3, I mean, yeah, 3. I did it right. All right, so it's easy when they give you the same base. It's a little more complicated when you don't. Okay, so here we have 3 to the 5th equals 9 to the 2x. Okay, so we need to have the same base. Right now we have a 3 and a 9. Those are not the same, in case you didn't know. All right, so we want to take the bigger of the base and rewrite it as an exponent using the smaller base. Okay, so we want to rewrite 9 as a base of 3. So 9 equals 3 to the what? Hoping you know it's 3 squared. Okay, 9 is equal to 3 squared. So now we're going to replace this 9 with 3 squared. I'm not changing the values. Okay? It's still the same value. It's just written a different way so that I can solve these exponentials. Okay. Little recap on multiplying. Whenever you have an exponent multiplied by an exponent, I'm sorry, an exponent raised to an exponent, you multiply them. Change these letters, make it easier. Okay, so let's say we had x to the a raised to the b power. Okay, that's going to equal x raised to the a times b. So here, 3 squared raised to the 2x becomes 3 raised to the 2 times 2x, which would be 3 to the 4x. Don't have to do anything on the left-hand side. Keep leaving it as 3 to the 5th. So now that our bases are the same, we have a base of 3. All we need to write is 5 equals 4x. And divide by 4. So we get x is equal to 5/4. Show you another example here before I give you some to try on your own. Okay, keep it fairly simple here. Okay, do we have the same base? We do not. Okay, we need to take the bigger one and write it as a base of the smaller one. So 25 we can write as 5 squared. So now we've just rewritten it. 5 raised to the 4 minus x equals 5 squared. Our bases are the same. So essentially, we can cancel out our bases if that helps. So 4 minus x equals 2. So we get negative x equals negative 2. Divide both sides by negative 1. We get an x value of 2. Okay, try these two on your own or with a neighbor. Let's get on the first one. We got to rewrite 36 as a base of 6. So we change that to 6 squared. Okay, so now you have an exponent raised to an exponent, so you multiply them. We get 6 to the 4x. Left side stays the same. So now we just need to set our exponents equal to each other. 2x minus 3 equals 4x. Subtract the 2x over here, gives me negative 3 equals 2x. Divide by 2. X should equal negative 3/2. All right, second one a little bit different. Okay, we have a big number here, or smaller base here. Okay, can we rewrite 27 as a base of 3? Yeah, it's 3 to the 3rd. Okay, so for the most part, we've only been doing squares. Okay, it could also be asked to do cubes. Okay, so 3 cubed is 27. So now that my bases are the same, you set it up so my exponents equal each other. Divide by 2. X equals 3/2. Try 2 more? All right, let's try 2 more. Second one's kind of tough. It's very tough. Give it a shot, though. All right, so the first one, pretty simple. Got to change 81 to be a base 9. So I get 9 squared. So 9 to the 2x equals 9 squared. So 2x equals 2. Divide by 2, x is just equal to 1. Okay, so second one's a little tricky. Okay, I wouldn't expect you to know how to do this. Maybe you could have been super smart. I don't know. Okay, 27 is the bigger number. Okay, but can we write 27 as a base of 9? Okay, your first instinct is to write like 9 cubed, right? But that's 9 times 9 times 9, which equals 729. Okay, that's not 27. We can't do that. Okay, so what we have to do is we have to write these both as a base of 3. So we have to change both of these. So the 27 we change to 3 cubed. The 9 we change to 3 squared. So now we multiply the 2 by 2x, which is 4x, the 2 by negative 5, which is negative 10. So we get 3 to the 4x minus 10 equals 3 to the 3rd. So now 4x minus 10 equals 3. Add 10 to both sides. Divide by 3. And so x ends up equaling 13 over 4. Okay, good thing about this too is if you have a calculator, you can always go back and check. All right, if I plugged in 13 over 4 into that, so let's say I say 9 raised to the 2 times 13 divided by 4 minus 5, should get an answer of 27. Survey says I get 27. I am so smart. Okay, so you can always go back, plug it back into x, make sure that it equals whatever it is it's supposed to equal. Okay, and you're good. All right, so the other thing to go over today is called fraction busters. That's fun, huh? So let's say we have a problem like this, x over 2 plus 3/5 equals 3. Seems difficult to start, but what we want to do is we want to have a common denominator. Okay, it's the bottom part of the fraction. And solve for x in the numerator. That's the top part. Okay, so we find a common denominator of this. A couple of different ways you can do it. You're looking for a number that's divisible by all 3 of these numbers. Okay, you can always just multiply them together. That always works. Okay, sometimes there's a smaller number. Okay, so in this case, what number is divisible by both 2 and 5? What number is divisible by both 2 and 5? 10, right? So we want to have a common denominator of 10. So to make our denominator 10 here, we need to multiply by 5. And whatever you do to the bottom, you have to do to the top, or else it changes the number. Okay, the second term, we want to multiply top and bottom by 2. And the third number, we want to multiply the top and bottom by 10. So now we get 5x over 10 plus 6 over 10 equals 30 over 10. All right, so now we can just essentially get rid of our denominators and solve for the numerators. Okay, so this equation, for this to work, the numerators have to equal out. So 5x plus 6 equals 30. Get 5x equals 24. I get x equals 24 over 5. Okay, on test, just kind of this is a 100% correct answer. No need to do anything else. So I always see people trying to go like 4 and 1/5 or 4.20. Okay, you don't need to do that. Okay, odds are you're going to make a mistake going from this to one of these two values. So just don't even do it. Just leave it 24 over 5. Very acceptable answer. All right, walk you through another one here. Okay, so we got denominators of 1, 5, and 3. What's our common denominator going to be? 15, right? Put this over 1 real quick. So we multiply top and bottom here by 15, top and bottom here by 3, top and bottom of by 5. That way we get 15 on all of our denominators. So 15x plus, or 15x over 15 plus 6 over 15 equals 5 over 15. Cancel out our denominators. 15x plus 6 equals 5. Subtract 6 from both sides. So I get x equals negative 1 over 15. All right, you ready to spread your wings and fly on your own here? All right, try these two on your own. All right, it's going around. Looks like everybody got the right answer. Common denominator for 3, 2, and 6 is what? 6, right? So let's say maybe you didn't know that. Worst case scenario, you could always multiply the 3 together, right? So in this case, 3 times 2 is 6. 6 times 6 would be 36. Okay, so let's say I want to have a common denominator of 36. Walking around, I didn't see anybody do this, but I'm just kind of showing you worst case scenario. Maybe you didn't know. So if I want a common denominator of 36, I got to multiply this top and bottom by 12. I got to multiply top and bottom here by 18 and top and bottom here by 6. Okay, so I'm going to get some fairly big numbers. That's okay. It's not the end of the world. Okay, 4x times 12 is 48x. 3 times 18 is 54x. Okay, and 17 times 6 is 102. Okay, so I got some bigger numbers. Again, be okay. Because 48 plus 54 is 102x equals 102. And I still should have gotten the same answer that you guys all got, which is 1. Okay, so yeah, if you could figure out that the common denominator was 6, your numbers are going to be a lot smaller. It makes it a little bit easier for you. Worst case scenario, you just multiply the 3 numbers together, and you go from there. Common denominator of 2, 6, and 9. Anybody? Sure. 18, right? So to get 18, I got to multiply top and bottom by 9, top and bottom by 3, top and bottom by 2. So I get 9x over 18, I get 15x over 18, and I get 2 over 18. Cancel out my denominators. 9x plus 15x equals 2. 24x equals 2. Divide both sides by 24. Reduces down to 1/12. Just be careful. You see 24x equals 2. Your instinct might be to write 12. Okay, just make sure you do all the math right. Divide by 24. 2 over 24 reduces down to 1/12.